Okay, guys, what do you say here? Let's move on. It's a second day of indirect proofs. Second day of indirect proofs. What's going to change? Nothing. Nothing's changing. The process is still going to be the same. Assumption. We're going to contradict a given. And at the end, we're going to write assumption led to contradiction. All right, that's not going to change for us. Here's what you will find today, and I'm just going to get this in your mind to just warn you. Here's what you are going to find. You know what you need to contradict, but it's going to be tough, might be tough to do that. All right, so expect a little uncomfortableness here. All right, Friday wasn't too bad. Once you picked up the process, it was very easy to find what you needed to contradict and to do it. Maybe not so easy to do the contradiction today, but we'll see. I might be totally wrong and you guys just fly by these. Let's find out. So go ahead on number one. I'll give you guys a second to set up statements, reasons. Write in your givens. Triangle ABC is scalene. All right, first thing I got to ask you, and this is just reviewing from Friday. How do I know I have to do this proof indirectly? I know because it says it at the top of the page. That's the unit we're in. But let's say it's June and we're taking the Regents exam. I'm looking at this proof. How do I know, oops, I got to do this thing indirectly? How do I know I have to do this indirectly? Let's start this off. Number 6. I'm going to have these memorized by the end of the year. Christo, how do I know this has to be done indirectly?
Well, I mean, you're trying to prove something isn't with like a slash in the proof section.
There you go, right here. Proving something's not happening, that automatically signals to me it's got to be, this proof has to be done indirectly. And when it's done indirectly, you start out by saying you're going to assume something's true. So here, back to the proof. What am I going to assume is a true statement here? Sarah, what am I going to assume is a true statement?
That AE is congruent to CD.
There you go. We're going to assume that segment AE and segment CD are congruent. Always the opposite of your proof statement. Always the opposite of your proof statement. All right, now let's go to our givens. We have 2 givens, ABC scalene and AE and CD are altitudes. We have to contradict one of them. This is why it might be a little tougher for some of you, because over the weekend, you just saw the word not in the given and you're like, boom, go to contradict that one. Let's contradict that one that says not. I don't have the word not in any of the givens though. So we got to make a good decision here, a smart decision. ABC scalene, AE and CD are altitudes. You take a look right now and you figure out which one do you think you would want to contradict. ABC scalene or those are altitudes. You think about it yourself right now. Which one would it be easier for you to contradict? All right, I give you guys enough time here. All right, you tell me, out of those 2 givens, which one do you think you could say, I can contradict that statement? Woo, going down. Sean, what do you think, Sean? Which one could Sean contradict?
AE and CD are altitudes.
All right, how are you going to contradict that?
By proving that the angles like CDA and angles like AEC are not right angles.
All right, so here you go. You're going to prove it's not right angle, so now you're getting into more indirect stuff, right, Sean? All right, see that? I don't want to get an indirect proof on top of another one on top of another one. All right, so it's going to be other than the proof statement. That's the only thing I want to prove something's not happening. All right, try to stay away from that in the givens, everyone. All right, the only thing you want to prove not happening is in the proof statement, because then we start talking about more indirect proofs on top of more. All right, so let's go to the other one now. ABC is scalene. Well, first, somebody remind us, what is a scalene triangle? Nate, what's a scalene triangle?
No congruent sides.
Yeah, so how could you contradict that, guys? How could you contradict a triangle that has no congruent sides? Show it has what? Go ahead, chime in.
Congruent sides.
At least two, right? At least two. So basically what you're telling me here is, if you want to contradict it, show ABC is isosceles, right? That's basically what you're telling me. Two congruent sides, that it won't be scalene. That's a contradiction. So is everyone all right there? It gets a little bit tougher now picking which given you're going to contradict. But is everyone all right why we're going to pick that one versus the other altitudes one? All right. Can we get triangle ABC to be isosceles? So I will have a contradiction. Can I do it? Can we do it? How do I get ABC to be isosceles? Well, I got to prove two congruent sides. And usually, if we're going to prove two sides congruent, we're usually going to say CPCTC, so we're going to need two triangles congruent. So I'm going to let you guys look at the diagram and see if you can name me two triangles that I should prove congruent so I could get two sides in ABC to be equal. Do you see any triangles maybe I want to prove congruent? And remember, I already have this as an assumption, AE and CD. So probably pick triangles that have AE and CD and are also sides in triangle ABC, right? I want to try to pick two triangles that do both there. Contain AE and CD and also have sides in triangle ABC. All right, anybody see any here and we want to try to get? Woo! Zane, here we go. Any two?
Wouldn't triangle DCB and triangle AEB work?
We could try it. It fits into what I needed. That's for sure. Here you go. This triangle has AE, and it's also got BA, which is a side in triangle ABC. That works. And also BDC would work as well because we got DC, and we also have side BC, which is in ABC. Yeah. Yep. Let's try it. I don't know. Let's try it. The worst that can happen is we can't prove them and we got to pick another pair. So let's see. Could we prove these two triangles congruent? Where I already have a pair of sides, right? AE and CD. What else do we have in those? Anything else you could tell me is true in those two triangles? Sanjay, anything else you could tell me is true?
EDC and CDB are congruent.
Okay, yes, they will be, but how do you know they're congruent? There's like an in-between step there. How do you know those two angles are equal?
Oh, they're right angles.
Okay, and okay, I'm going to keep even going deeper. How do you know this one and this one are right angles? How do you know, where did that right angle come from?
CD and AE are altitudes.
Thank you. I know Sanjay knows the vocab. Again, altitudes form right angles. Medians go to the midpoints. All right, altitudes form right angles. So you got a pair of right angles. I got a pair of sides. Anybody see anything else I could use in those two triangles? Because I'm not there yet. Zane's triangles aren't congruent yet, so I'm not sold on those two. I got a pair of sides and a pair of right angles. Anything else to finish them? Ella, anything else?
Angle B is congruent to angle B.
All right, so it looks like I'm sold now. All right, we can prove those triangles congruent. I'm sold. If I couldn't, we'd go on to a new pair. All right, I'm sold. All right, so let's see. I'll start Since it's just fresh with L as angle B, congruent to angle B. Reflexive. What else? We already had the sides, so now I go back to Sanjay, which said angle BDC and angle BEA are right angles. Just to make sure I know people were paying attention to this and you know your vocabulary, why are they right angles again? How did Sanjay know they were right angles there? Sarah, how did I know they're right angles there?
Because their altitudes.
Yep. So I don't know what we wrote on. What did we write on Friday? Definition of an altitude. Altitudes form right angles. Either one works. Altitudes form right angles. But still need to say, just like we always have all year long, right? That's great that they're right angles, but for them to count as an angle, you got to say they're congruent. There it is. All the sides and angles I need now to those two overlapping ones. So we have enough info to confidently say triangle BEA congruent to BDC. I just need somebody to tell me why. Why are those two? What method now? Again, hey, if you guys can't see it, if you can't see the method, just take one of the triangles out right now. So if I took triangle BDC out, put all the markings on, so I had a right angle at D, a reflexive angle at B, and a side at CD. I think the method becomes very easy now if you draw it out. What is the method these two triangles are congruent? Quinn, what do you got for my method here?
Angle, side.
Here you go. Clearly that angle's not in between. I mean, that side's not in between. Good job. All right, we got the triangles congruent, so we could say if the triangles are congruent, what do we need from those two triangles to be congruent now? There you go. Tyler, what's congruent now if those two triangles? A lot are congruent, but specifically, what do we need congruent, Tyler?
Side BA, or line BA and line BC.
There you go. Reason?
CP, CTC.
Yep. Uh-oh. Uh-oh. If BA and BC are equal, that means triangle ABC is what? If I got BA and BC congruent, what type of triangle is ABC then? Sarah, last one for you today.
Isosceles.
Oh, that's a huge issue, huh? Sarah, how'd you know it was isosceles?
Because it has two congruent sides.
There you go. Two congruent sides implies an isosceles triangle. Yep.
I have a question about this.
Oh, yes. Hopefully I'll have a response.
So instead of that, could you just put the same thing that you put in the statements for the reason for number 8? Like the statement in number 7 is for the reason number 8, or do you have to write that out?
I have no idea what you're talking about.
Could you, instead of saying two congruent sides is isosceles triangle, could you just put BA is congruent to BC?
Oh, yeah, absolutely. Yes, Crystal. That's perfectly fine.
Okay.
Yep. Perfectly fine. All right, everyone. We got a problem right now in your proof. Oh, big problem, right? I'm shaking. ABC's isosceles, but you told me it was scalene in the givens. I don't think it can be both at the same time, right? So like we did on Friday, what led us to ABC being isosceles? It was that darn assumption. Because we assumed AE was equal to CD, it led us to this false statement that ABC was isosceles. So that assumption is false. The assumption is not true. It is false. So you know that the opposite, AE, not congruent to CD. Assumption led to a contradiction. And as you remember, in your brackets, and this really just solidifies to me that you know 100% how these work, show me what lines your contradiction was on. So it would be step 1. And where did we contradict step 1? 8. Okay? Questions? Comments? Any concerns there? Ask away, guys. Please ask away. Please, guys, anything? All right, I'm going to do just one more with you, and then the rest is yours. Yours to take. So go ahead. One was congruent to 2 here. Okay, here we go. What are we assuming is true in this one? We're going to assume what is true here. Here we go. Nate, what are we going to assume is true, Nate?
That AB is congruent to CA.
Yes, yep, we're going to assume that's true. And make sure, again, as soon as you write it, don't forget about it. You can use it. Use it in your proof that AB and AC are equal. We can use that. All right, let's go to what we're going to contradict. We got 2 givens again, 2 of them. I got 1's congruent to 2, and I got AD does not bisect CAB. I think this, I think anyway, from Friday's talk, that this is a pretty easy one. Which one are you going to try to contradict in your proof? 6, here we go. Christo, which one am I going to try to contradict?
I'd say that AD does not bisect angle CAB is one you're trying to.
Yeah, that would be pretty easy, right? To contradict it, I would just need to say the opposite, which is it does bisect. So can we get AD to bisect angle CAB? That's our goal. Can we do that? Can we get line segment AD to bisect CAB? I don't feel good right now. I don't feel good doing that. How do I do that? How do I show AD is going to bisect CAB? I'm not comfortable right. How do I do that? Anybody suggestions? Open it up there. If AD, go ahead.
By proving an angle O, by proving an angle O, maybe by proving an angle BAD
Yep.
BAC.
You got it. If you guys can show me that DAC and DAB are equal? I got you. I believe you. If you show me BAD and DAC are congruent, I believe you. AD will be a bisector. All right. I'm going totally hands off here. Totally hands off. How do I prove those two angles are equal then? Well, any true conclusions from my diagram you can get me to? Hopefully it'll lead to BAD and DAC being equal. Where do you want to lead me here, guys?
We can try and prove triangle BAD is congruent to triangle BCD, and then we.
Whoa. BAD and BCD. Aren't we trying? There you go, Tyler. Aren't we trying to prove these two angles equal?
Yes, but then because we could prove angle 2 is congruent to angle BAD, we could subtract the whole angle, which we know are congruent because these two sides would have to be congruent because CB, CTC, BA, and BC. So then you could subtract, you know that it's an isosceles, so those two angles are congruent.
Yep.
Then you could subtract the smaller angle that we just found congruent to each other, and you know that those parts have to be congruent.
Okay. I followed your thinking there, and I'm all right with it. I think we can do it quicker, though, is my only rebuttal. All right, we can do it your way. That's fine. I think we can do it quicker, though. Get those two angles congruent quicker.
Can't you say that BD is congruent to DC?
We can start there. We'll definitely start there. BD congruent to DC. I'll write all this down in a second. I'm just marking my diagram with what you guys tell me. I can say BD is congruent to DC. I don't know if everybody knows why, but we'll get to the reason when I write it down. All right, what else is true? BD congruent to DC. Good start. Remember, I'm trying to get these two angles equal eventually. So where do you want to keep going with?
AD is congruent to AD.
All right, there you go. And this is why a lot of people don't like this proof, is because do you see the two triangles we're going to prove congruent, guys? Sorry that they're not to the right and left of each other. They look a little strange, right? BAD and CAD. Everyone see those two triangles we're going to try to prove congruent? Yeah, they're congruent. And then we could say CPCTC the angles are. All right, good work. Let's just put it all together now. So let me go back to BD being congruent to DC. Quinn, did you give me this one?
Yeah, I did.
Good. Don't give me the reason then. Somebody else can give me the reason. Sarah, you're good for today. Great job. Great job. Great job. Here we go. Liam, do you know why those two sides are equal?
I don't.
All right. 1 and 2 are congruent, correct?
Yes.
What type of triangle is BDC? If angle 1 and 2 are congruent, that makes triangle BDC what type?
It's an isosceles triangle.
And in an isosceles triangle, what is always located across from the two congruent angles?
The two congruent sides.
There we go. In a triangle, congruent angles are across from congruent sides. That's why BD and DC are equal. I don't need to ask anybody why AD and AD are equal. That's reflexive. I will have to ask somebody, though, why the triangles are congruent. Triangle BAD congruent to CAD. I know, not the most appealing triangles to look at as far as your eyesight goes, because usually you guys like them right next to each other, on one on the right, one on the left, or one on the top, one on the bottom, and that's not the case here. But we can still prove them congruent by Niall? How can I prove these two triangles congruent? And it looks like we're taking a little break there. All right, I see you. Number generator will remember that. Watch, guys, it'll remember. 10, here we go. Adam, what's the method?
Side angle side,
Where's your angle?
1 and 2.
Okay, let me back up and be calm here. What two triangles are we proving congruent?
BAD and CAD.
And 1 and 2 are in those triangles?
Oh. Side.
All right, side. Remember why we proved the two triangles congruent. Now you know angle CAB is congruent to, not CAB, I'm reading the wrong, BAC, BAD, come on, one job. Try that again. Angle BAD now is congruent to triangle DAC. CPCTC. And if those two angles are equal, what do we know about segment AD now? If those two angles are equal, what do we know about segment AD? Liam, here we go. If those two angles are equal, what's AD doing?
AD is bisecting CAB.
There you go. So now we can say AD bisects angle CAB. What would be a good reason here? How do I know it bisects? And I don't want definition of a bisector either. AD bisects CAB. Why? And again, definition of a bisector doesn't tell me anything. How do I know it's bisecting? Ooh, there we go. Ellie, how do we know it's bisecting?
Because angle BAD and angle CAD are congruent.
I love it. That's, you could write just that. You can just write BAD congruent to DAC. Love it. Perfect. Or you can write a bisector splits an angle into two congruent angles. Fine. Oh, really, Niall? All right, there we go. There's the reason of 2020. Don't worry. Generator's going to find you again. Don't worry. I have faith. All right, now you got yourself a contradiction, so we'll end it right here. That must mean my assumption is false. Assumption led to a contradiction. And you guys know I always like, what steps did that contradiction occur in? I'd like to know from you guys, what steps in our proof did we have our contradiction? Nate, where was our contradiction here, Nate?
1 and 7.
There you go. Always a given. And then wherever in the proof you contradicted that given. All right, that is it for me. You guys are going to start practicing. On number 3, I'll give you a little tip on number 3 so you don't struggle right off the bat. Number 3 has nothing to do with proving triangles congruent. All right, number 3, when you try to contradict one of the givens in number 3, you will not do it by proving triangles congruent. Just a heads up. Okay, so don't go down that road because you'll never find your way back. Okay, so do not prove triangles congruent in number 3. please use this time to practice and open up your mics, please. If you have a question or concern, open it up. All right, guys, we'll end it right here. Again, if you're struggling with something, reach out to me, please, so we can make a plan of action. But everyone prepare for the test on Wednesday, because if we're all remote on Wednesday, we're taking that test on Wednesday on formative. All right, if not, we'll go with the original plan Wednesday and Thursday. Okay, but for now, get your mind ready to take it on Wednesday. All right, have a good day, guys.